These are solutions to Melham's Chapter 3 test for Calculus 1, Math 251 at CSM. Okay, number 1, the function was square root of x, which we want to think of as x to the 1/2. Derivative of x to the 1/2 is 1/2 x to the negative 1/2, 1/2 radical x. Plug in 25, 1/2 radical 25, 1/2 times 5 is 1/10. So y minus y1, y minus 5 equals m 1/10 times x minus 25. Number 2, there's an easy way and a harder way to do it. The hard way is to just go ahead and do it with the quotient rule. So bottom times derivative of the top, minus the top times derivative of the bottom, all over the bottom squared. Multiply this out, 2x squared minus 3x plus 1 minus x squared plus x, that should be an x there, over x minus 1 squared. This comes out to be x squared minus 2x plus 1, which is exactly the denominator. The answer is 1. Okay, that's the hard way. The easier way was to realize from the start, you could have factored the numerator into x times x minus 1. These cancel out, so the function is just x. Therefore, the derivative is also 1. Okay, 3, you just have the basic 6 trig functions. Every other one is a minus sign. All of them should end up with a positive because all the ones that require a negative have a negative coefficient, negative cosine, negative cotangent, and negative cosecant. Means they're all going to be plus. So cosine x plus sine x plus secant squared x plus cosecant squared x plus secant x tangent x plus cosecant x cotangent x. Number 4, f prime of t is same thing, 3 to the t sine of 2t times natural log of 3 times the derivative of the exponent. So that's a product. So first function is t times the derivative of the second, derivative sine of 2t is cosine of 2t times 2, stuck in the 2 there, plus second function, sine of 2t times the derivative of the first, but the derivative of t is 1, so you don't have to put it. So there's my answer. Number 5, negative 2x plus product rule, 3x dy dx plus y times 3 plus 2y dy dx equals 0. Leave the dy dx's on this side, move to the other side, the negative 2x, it'll become a positive. Move over to 3y, it'll become a negative. Factor out the dy dx. So 3x plus 2y dy dx equals 2x minus 3y. Divide by 3x plus 2y. So dy dx is 2x minus 3y over 3x plus 2y. Number 6, call it y equals x to the x. Take the natural log of both sides. Ln y equals ln x to the x. X comes down, x ln x. 1 over y dy dx equals product rule. First times derivative of the second, 1 over x, plus second function ln x times derivative of the first, which is 1. Multiply both sides by the original y. So dy dx is y, which is x to the x, 1 plus natural log of x. Number 7, rest means the derivative is 0, velocity is 0. So I just set the derivative equal to 0. 2t minus 40 equals 0, means t is equal to 20. They don't give me any time there, so I don't have to give it seconds or hours or whatever. Number 8, the initial amount was given to be 100. Half-life is 5730 years, so 5730 goes here. 50 goes here, that's half of 100. Divide by 100, 0.5 equals e to the 5730k. Take the natural log of both sides. ln of 0.5 is 5730k. Divide by 5730. K is ln 0.5 over 5730, negative 0.000121. So my equation becomes a of t is 100 e to the negative 0.000121t. Okay, now I just plug in 50. It says how much is remaining after 50 years. Plug in 50, 99.40 milligrams. Okay, number 9, you have one car going west, 40 miles an hour, one going north, 30 miles an hour. I call that X, call that Y, hypotenuse is Z. And it says they're going for 3 hours. So 40 miles an hour for 3 hours means 120 miles for X. 30 miles an hour for 3 hours means 90 miles for Y. Okay. 40 is dx dt. 30 miles an hour is dy dt. We're looking for dz dt, rate of change of the distance between the two cars as time goes by. All right, using my Pythagorean theorem to figure out the z, x squared plus y squared equals z squared. I know this is 120. I know this is 90. So 90 squared plus 120 squared equals z squared. 8100 plus 14,400 is z squared. Z squared is 22,500. Take the square root. Z is 150 miles. Okay, so I have x is 120 miles, y is 90 miles, z is 150, dx dt is 40, dy dt is 30, and solve for dz dt. Okay, so 2x dx dt plus 2y dy dt equals 2z dz dt. Divide both sides by 2z, the 2's cancel out. So dz dt is x dx dt plus y dy dt, all divided by z. And now I plug in. So this was, x was 120, dx dt was 40. So 120 times 40 plus y times dy dt. Y is 90, dy dt is 30. So 90 times 30 divided by z, which is 150. Punch it in your machine, 50 miles an hour. Okay, you must show me this. It's not acceptable to make a right triangle and say 30, 40, 50. That only works for distances. That does not work for rates. Okay, so you have to show me this. Okay, number 10, f of x is x cubed at the point 2, 8. F prime of x is 3x squared. Plug in 2. F prime of 2 is 3 times 2 squared, which is 12. Y minus y1 equals m times x minus x1. This is 12x minus 24. This time, keep going, add 8 to both sides. So y equals L of x, the linearization function, is 12x minus 16. So now to approximate 2.01 cubed, I plug in 2.01 here. Much easier than using the actual function. Okay, so 12 times 2.01 minus 16 comes out to be 8.12. This is the answer, 8.12, but just to see how good the answer was, the actual value of 2.01 cubed is 8.120601. So the 8 matches, the 1 matches, the 2 matches, the 0 matches. So we don't get a divergence until the 6, which is the tenths, hundreds, thousands, 10,000ths place. So by cheating, instead of using the actual function, I just used a straight line. We lost accuracy, but only not until the 10,000ths place do we get an error. Number 10, prove that sinh x prime is cosh x. So sinh x prime, sinh by definition, it's e to the x minus e to the negative x divided by 2. I could use the quotient rule, but it's a lot easier to factor out the 2 and make it 1/2 times e to the x plus e to the negative x. So take out the half. Derivative of e to the x is e to the x. Derivative of negative e to the negative x is negative e to the negative x times -1. That makes this a plus, which I can rewrite as e to the x plus e to the negative x divided by 2. And by definition, that's cosh x. So that's how you do problem 11. All right, so this is exam 3 from Melham's Math 251, Calc 1, exam 3, solutions.